Population proportion. Before we move on to talk about how to construct and develop a confidence interval for population proportion, let's review what proportion is. Proportion, which is shown by P, is the proportion of population that have a characteristics of interest. For example, the proportion of female students in a class, the proportion of students majoring in accounting, the proportion of population that has contracted a virus. P hat, on the other hand, is the proportion of sample, which is an estimation of P. The formula for P hat is equal to P hat is equal to X. X is the number of items or individual in the sample that have the characteristics of interest. N is the size of the sample. P hat and P, the proportion, is a value between 0 and 1, always. It's always restricted between a value 0 and 1. If we define X as a random variable representing the number of items in our sample that have the characteristics of interest, then X would follow a binomial distribution with N and P. P hat is approximately distributed as a normal distribution when N is large, and also when N multiplied by P is greater than 5, and N multiplied by 1 minus P also is greater than 5. So when these three conditions hold true, N is large, N multiplied by P is greater than 5, N multiplied by minus P also greater than 5, then P hat would follow a normal distribution, approximately a normal distribution. Since it follows, if the proportion P hat, the sample proportion, follows a normal distribution, given that the conditions hold true, then we can find the standardized actually P hat. So P hat would follow a normal distribution with an average of P and a standard deviation of P multiplied by 1 minus P over N. Then we can standardize P hat using a Z distribution. So P hat follows a normal distribution with an average of P and a standard deviation of P multiplied by 1 minus P over N, a square root of that. Then Z is equal to P hat minus its average, which is P, divided by a standard deviation, which is this one, would follow a standard normal distribution, or Z distribution. Review an example. If the true proportion of voters who support proposition A is 40% or 0.4, what is the probability that a sample of size 200 will yield a sample proportion between 0.4 and 0.45? So here we want to find the probability that P hat, the sample proportion, is between 0.45 and 0.4. We cannot find a probability unless we know the distribution of the probability. So what is the distribution of P hat here, the random variable here? Well, let's check if P hat is eligible to follow a normal distribution. So first of all, N is here 200, which is large enough. So we're gonna check the other two conditions. N multiplied by P must be greater than 5. N here is 200 multiplied by P, which is 0.4. So N multiplied by P is 80. 80 is greater than 5, yes. So this is also hold true. n multiplied by 1 minus p also must be greater than 5. So you see, if this is true, 200 multiplied by 1 minus 0.4, which is 0.6, that's 120. And 120 is greater than 5. So all three conditions hold true. That means that p hat follows a normal distribution with an average of p and a standard deviation of a square root of p 1 minus p over n. So now we can find the probability because we know that p hat would follow a normal distribution. So basically this is finding a normal distribution. So we can convert it to z distribution and find the probability. So let's see, first find the standard deviation of p hat. The standard deviation is the square root of p multiplied by 1 minus p over n, which is 0.4 multiplied by 1 minus 0.4 over 200, which is about 3%. So that's the standard deviation. So now we can actually convert our distribution to a z distribution. So the probability that p hat is between these two values, we're going to convert this to z. And so we have to find the z of 0.45. This is z of 0.45, and also z of 0.4, which is this is z of 0.4. And these are two. So z of 0.4 is 0, and z of 0.45 is 1.44. So if you find this probability, the probability that z is between 0 and 1.44 is actually equal to 0.4251. So that's the probability. That's the probability that p hat is between 0.4 and 0.45 is 0.4251. So just to make sure that you remember how to compute this probability is equal to the probability that p hat is less than 0.45 minus the probability that p hat is less than 0.4. So you convert this to the z distribution, also this to z distribution, and find the probability. Or here, this would be equal to the probability that z is less than 1.44 minus the probability that z is less than 0. You find these two values from the z table, then you subtract this value from this value, and it gives you the total probability. Now that we learned about population proportion, reviewed it, it's time to talk about a confidence interval for population proportion. So we learned that p hat is a point estimate for p, population proportion. But point estimates are not accurate. Most of the time, if not all the time, they are incorrect. That's why we build confidence interval to estimation. We already talked about confidence interval, how to build it for population average, mu, when sigma is known. We don't talk about this for now. So now we want to talk about building a confidence interval estimation for population proportion P. Let's again review the concept of point estimate and interval estimate. A point estimate is a single number. For example, we want to estimate the average. We would say we want to estimate mu, the average of the population. We use x bar, the average of sample, and it would be just a number, for example, 2.5. So it's just a single number. But interval, on the other hand, is a range. A confidence interval provides additional information about the variability of the estimate. So this is a confidence interval. The point estimate is right in the middle. And then we're going to build a right wing and a left wing around this, which are in the same length here. So the left side would be the lower confidence interval limit, and the right would be the upper confidence interval limit. And this is called the width of the confidence interval. Half of this would be the margin of error. Confidence interval general formula. The general formula for all confidence interval is as follows. Point estimate, whatever you want to estimate, whether you want to estimate the average or the proportion. Point estimate plus and minus critical value multiplied by a standard error. The plus sign would gives us the upper level range, and the minus sign would gives us the lower level range. Critical value is just the values computed from the Z table. For example, we want to compute the 95% confidence interval, then we have to find the Z of 5% here, or the Z of 0.025% here. So this is called critical value. A standard error is the standard deviation of the sample variable, random variable. So point estimate is the sample statistic estimation and estimating the population parameter of interest. Critical value is a table value based on sampling distribution of the point estimate and the desired confidence interval. Not necessarily it could be a Z distribution. We're going to talk about T distribution later in the next course, and that's also, it's a table value, which is T actually, so T of alpha over 2. So that's also a critical value. A standard error is the standard deviation of the point estimate. So here when we will talk about the population proportion, point estimate would be p hat. When we talk about the average mu of the population, the point estimate would be x bar. Margin of error is this multiplication, critical value multiplied by the standard error. This is called margin of error, ME. Let's build a confidence interval for population proportion. Confidence interval endpoints. That means the lower limit and upper limit, because that's all that matters. When you want to build a confidence interval, I'm going to give you two values at the end. One value is the lower limit, that's the endpoint on the left, and this is the point estimate right in the middle, point estimate. So this is the lower limit and this is the upper limit. So when you build a confidence interval, you need to give these two values, the upper limit and level limit. So the formula is point estimate plus and minus critical value multiplied by standard error. So for our example, if you want to build a confidence interval for proportion, that would be p hat, the point estimate is p hat, plus minus critical value is Z of alpha over 2, depending on what alpha is. A standard error is the square root of p multiplied by 1 minus p over a square root of n. Since we don't know what p is, we're going to use the estimation, which is p hat. Upper and lower confidence interval for the population proportion are calculated with the following formula. P hat plus minus Z of alpha over 2 multiplied by a square root of p hat 1 minus p hat over n. So this is a 1 minus alpha percent confidence interval CI for P, the population proportion. And of course, we need to, before we do that, we need to check whether this condition is hold true. That means that we can use the Z distribution here. So this is precondition. Assume that it's hold true. Since we do not know the value of P, we will estimate this with sample data. This is here. So instead of using P, we use P hat here because we don't know P. So this is the standard error here, which we use it here. And this is the critical value.